What you doing? Just looking at the different planets. Nice, I got a question though. What is it? Why are Jovian planets all located farther away from the sun? Good question. I was actually wondering the same thing too. Nah, I doubt that. It's a wonder that you can even wonder at all. You can barely find the instantaneous rate of change when you've given a literal graph. Anyways, let's start the video. Hello, it's me, Bloodbeats, and today we'll be talking about the layout of the solar system and the way it is. But before I start my explanation, we need to understand a few things. 1. Element formation. Our sun is made up of the nebula, left behind by the last star in its place. In fact, we believe that our sun is a third-generation star, meaning that 2 stars died before it. The previous stars would have used up their fuel, which is nuclear fusion, and contract into a white dwarf, then exploding into a supernova. The scattered material would be used to resupply the area with atoms, in which later generations could condense. Nebulae usually consist of basic elements such as hydrogen and ionized gas. In each star lives and dies, light nuclei is used to form heavier nuclei, which provides the energy of the stars as they burn. This is known as nucleosynthesis, the process of forming heavier elements with lighter ones. Later generations of stars, our sun, would start with a higher proportion of heavier nuclei. When the solar system is formed, a rotating circumstellar disk of dense gas would have surrounded the sun. This is known as protoplanetary disk. Of course, as the protoplanetary disk would be large, the parts closer to the newborn star would be warmer, and the parts further away would be cooler. 2. Element distribution. The temperature gradient of the disk, of course, would affect the formation of planets, causing a pattern in the planets. Turbulent motions within the protoplanetary disk and magnetic fields would have drained away some angular momentum, slowing down its spin. This allowed some materials to continue falling into the newborn star, while the rest could cool and condense. As this cooling process is taking place, gases would interact chemically to produce compounds, which would eventually condense into liquid droplets or into solids. This diagram from this website could explain this way better than I can, so these are the element distributions. The first materials to form from the heat would have been the metals or other silicates that form rock grains. As the temperature dropped, sulfur compounds and bicarbon and water-rich silicates, such as those now found a lot among the asteroids, would have also formed. However, in the inner parts of the disk, the temperature never really dropped low enough for materials such as ice or carbocaceous organic compounds to condense, which explains why terrestrial planets are close to the sun and Jovian planets are farther away. And with that, the video draws to a close. Thanks for watching, and please consider subscribing. This takes up a lot of my free time, so if you would like more of this content, don't forget to hit that like button and subscribe, blah blah blah. Okay, goodbye.